Okay. Okay, ji, Bismillah, Manan. So we're starting with the ATP topical. So my target today is just physical measurement quantities as that you're done with your exam tomorrow. Once you're done with the exam tomorrow, हम फिर बाकी topics भी करेंगे, ठीक है? If you will be able to come tomorrow, that's going to be a good thing. We can have the whole day for ATP. If not, then we continue taking online classes. It says to investigate the motion of an oscillating meters rule. I need all of you to take out your ATP past papers. This is question number one from the first chapter. Quickly. Okay, so student investigate the motion of an oscillating meter rule. So by oscillating, it means it has to have a pivot. It's going to move. So it's going to be this way or this way, right? Then sorry. Okay, man. It says to investigate the oscillating meter rule. He uses the apparatus shown in figure 1.1. There are clamps, there are vertical threads. This is the meter rule right in the middle. I'm going to highlight it for you. This is the meter rule. You need to understand that when you have a horizontal meter rule, you will be asked to definitely find out the height. And to find out the height, you have to measure this distance, height of the meter rule above the bench. Okay. It says to ensure that the meter rule is horizontal. Briefly describe how to check that the meter rule is horizontal. You can always do that by measuring the length of the bench, right? Of it says you may draw a diagram on the on figure 1.1 if it helps you explain your answer. So my question is, it says measure the distance of the rule from the bench using a meter rule or measuring tape to check if the meter rule is horizontal. Now, if you have to check whether the meter rule is horizontal, you need to understand that the bench has to be stable. It asks you, the bench has to be stable, and the stands have to be stable, and then when the meter rule is put onto the stands and the meter rule is hanging through threads, right? This is what allows it to oscillate. Now, when the meter rule is hanging, you have to make sure that the meter rule is horizontal. There is something called set square. This is what you call a set square. This thing that you have in your geometry box, these right angle triangles. This is what you call set square. You can place a set square here. You can place a set square here to see if the rule is horizontal. The meter rule is horizontal. These are meter rules that you put down. If you're using a meter rule, this is where you can put your set squares. Okay. So it says briefly describe how to check and it says one marker. It says measure the distance of the rule from the bench using a meter rule measuring tape to check if the meter rule is horizontal. So it is advisable that you use the word set square to measure whenever anything is perpendicular or horizontal. Next is the student moves the stand on so that the vertical threads are at the mark on the meter rule. So if you look at it, this is two exactly. Make sure you look at it very carefully in the examinations because ये 2.1 भी हो सकता है, 2.2 भी हो सकता है, might look to you as 2, so you better pay attention. So this is 2 here, right in the middle, and then you have 98. And because it's a meter rule has marking from 0 centimeters to 100 centimeters. The meter rule, 1 meter is 100 centimeters. So it's 98 centimeters minus 2 centimeters. Obviously, the question will give you the unit for such a question. It says calculate the distance between the threads. It is 98 centimeters minus 2 centimeters, which is 96 centimeters. Now he twists the meter rule in a small amount as shown in figure 1.3 and then lets it go so that it oscillates for a rotating motion. Because the meter rule is hanging on thread, इस वजह से थोड़ा सा भी आपको ट्विस्ट करते हो ना तो it oscillates, it goes up and down, and the examiner has already told you about one oscillation. Now these questions are easy for you to attempt. ये खुद भी करोगे तो आसान है, but you need to understand कि कुछ चीजें हैं जैसे protractor rule है, जैसे use of set square है, जैसे finding out the gradient using the triangle method, वो चीजें मैंने सिखानी है. I'm sure इसके बाद आप लोग को जरूरत नहीं पड़ेगी. It says he twists the meter rule, a small amount is shown figure 1.3, and then lets it go so that it oscillates in a rotating motion. He measures the time t for 5 complete oscillations, okay? And the time it takes for the ruler to go 5 oscillations is 3.63 seconds. That's already given to you. So just why it is useful to take a trial reading for this experiment. You need to understand कि पहले ये चेक करना होता है हम हम मीटर रूल को हिला के देखते हैं टू मेक श्योर कि 5 ऑसिलेशन का टाइम तो मेजर कर भी सकते हो कि नहीं, कि 5 ऑसिलेशन कम तो नहीं है, ये 5 ऑसिलेशन या तो बहुत ज्यादा है या बहुत कम है। अगर बहुत कम है तो ऑब्वियसली यू हैव टू इंक्रीज द नंबर ऑफ ऑसिलेशन। ऑलवेज रिमेंबर कि अगर जहां नंबर ऑफ ऑसिलेशन ज्यादा होंगी वहां पे यू हैव मोर टाइम टू स्टार्ट द स्टॉप वॉच एंड to stop the stopwatch. So you need to understand you have to have a reasonable amount of oscillation to calculate the average time. So it says suggest why it is useful to take the trial reading for this experiment to see if the time is measurable for 5 oscillations. If it is not measurable for 5 oscillations, then it gets difficult for you. Then you need to understand that you need to increase the oscillations. Okay. Then it says the student carries out the same procedure for D values. D is distance, 20 centimeter, 30, 40, 50, and 60. His readings are shown in the table. Now you need to understand, this is a very technical question. You need to understand that this is distance and this is T is the time of oscillation. For 5 oscillations for a meter rule, that is 20 centimeters, the distance between the threads is 20 centimeters. The time taken for 5 oscillations is 17.85 seconds. As the distance increases, what do you think? The time decreases, yes or no? So if you are increasing the distance of the thread, this means you're making these threads of clamps go to the right, this one to the right, this one to the left. The threads are now holding it here. And if they're holding it here, this means there is a greater amount of distance between the threads. This leads to a lesser amount of motion. So the meter rule will not move so much. Why? Because the distance between the threads is, and when you hold the meter rule using threads on the edges, you need to understand that the meter rule becomes more stable. The more the stability of the meter rule, the lesser its movement or the moment, right? So it says, as we've discussed, because हमने ये क्यों डिस्कस किया, हर टेबल में प्लीज whenever you attempt a question for ATP, हर टेबल को पहले जज कर लिया करो, because they might ask you to state what relationship is between distance and time or whatever it is. So between two values in the table. Please make sure whenever you see a table, that's one thing that should be your instinct to check for the units on the table. There might be a part that would require you to put units on the headings of the table, okay? And there is a high chance that you're going to miss it. So please make sure you do that. Now, I get to 0.28 easily, but you need to understand you can't get to 0.28 if you don't read this formula. It says, for distance d equals to 20. So the examiner is going to help you explain calculate and record in table 1.1 the value of 1 over t, where t is the time for one oscillation of the meter rule. It's for one oscillation, right? Use the time, use the value of time t from the table and the equation 1 upon t equals to 5 upon t. अब mostly पता है मैं क्या बच्चे क्या कर रहे होते थे, हमने देखा कि 1 upon t equals to 5 upon small t है. I know that small t is here, right? So 1 upon t is going to be 5 over say 17.85. And then what most of students would do is they would cross multiply to find out time period. This was not the heading for the third column. It is just 1 upon t. So in this case, you're not touching the left-hand side. You're not cross-multiplying. You're not finding out the time period. It is just the left-hand side that has to be left idle. And whatever is the answer on the right-hand side is going to be the answer that you put in your table. So it's 5 divided by 17.85. That gives you 0.28011. And another very important point for ATB calculation, सबको आती हैं, सब कर लोगे, but 0.28011 has a lot of decimal places, right? You need to understand whenever you plug in the value in a table for an ATP question paper, you will look at the other values. If the other values are correct to 2 decimal places, you will also put down your answer as 2 decimal places. You're not going to go for 3 decimal places. So you're going to follow the rule. Why? Because these are repeated experiments that students do in the lab. Because you're not doing it in the lab, which means these experiments have already been repeated. And if they're already repeated, this means that all you have to do is to follow the rule. It's 2 decimal places, you put it to 2 decimal places. If it's 3 significant figures, you put it to 3 significant figures. Here I've made a comment. Your answer should be correct to 2 decimal places relative to the readings on the table. Please make sure of that. सब आता है आपको, I'm sure, but ये चीजें बहुत काम करती हैं. 1 markers can lead to a loss of grade marks, right? Plot a graph of distance d centimeters on y-axis. So what I've seen out of my experience, बच्चे y-axis और x-axis को पहले तो एक कुछ बच्चे ऐसे भी होते हैं जो y-axis x-axis को
लेबल ही करना भूल जाते हैं या डिफरेंट वैल्यूज ले लेते हैं. So what if Sabha plot 1 upon t on the y-axis? The examiner is not going to give you a single mark because you did not follow instructions. अगर ये ए लेवल्स में जाओगे इंशाल्लाह फिजिक्स लोगे और इसका प्रैक्टिकल कर रहे होगे और उसका ग्राफ बनाने को आएगा तो एग्जामिनर बोलेगा यू डिड नॉट फॉलो द इंस्ट्रक्शंस प्रॉपर्ली, सो योर एक्सपेरिमेंट इज कॉम्प्रोमाइज्ड एंड व्हेन योर एक्सपेरिमेंट इज कॉम्प्रोमाइज्ड यू विल नॉट गेट अ मार्क. So please take this as if you're conducting the experiment in real life. इससे प्लॉट ग्राफ ऑफ डिस्टेंस दी. मुझे पता था कि जैसे जैसे डिस्टेंस बढ़ता जा रहा है वैसे वैसे 1 upon t भी बढ़ता जा रहा है. You look at this combination, so 20 to 60, this quantity is increasing and so is 0.28 to 0.88, right? They might not be increasing proportionately, but they are increasing. If one quantity is increasing, the other is also increasing. If the change between the increase brings about the same change in every increase in the third column, then we say it is directly proportional. If it is not directly proportional, then you do not write it as directly proportional. I'll give you example for directly proportional. देखो 0 है 5 है तो एक टेबल बना रहा 0 5 10 50 and 20 and your answer for this is 10 20 30 40 50. You need to understand that for two quantities to be directly proportional, agar change in this value is 5 and this value is 5 and this value is the change in the first readings in the first column is 5, and if there brings about same change in the values of the second column, then we say that these two quantities are directly proportional. You will not use the word directly proportional until you see that an equal change in values of the first column brings about an equal change in the values of the second column. Please make sure you note this point, okay? Then we plotted the graph. मैंने plot कर दिया. What is most important are these two boxes. It says, don't forget to label the axis. The examiner in your marking comment has given me a comment saying the students forget to label the axis and to state the unit. So they might write down d and 1 upon t, but they will not write down centimeters or 1 upon second. But you need to understand कि examiner के पास वैसे ही एक mark है award करने का. He cannot give you partial marks. There's no 0.25, 0.5, 0.75. So either you write full all of it properly and then you get a mark. If you write incomplete things, the examiner is going to deem that to be incorrect. So please make sure you don't forget to label the axis and state the units. ये आप देख सकते हो on the screen. Now, whenever you find out gradient, use the triangle method. I'm going to erase all of this and I'm going to try and use the triangle method again for you guys. ये अभी हम मिटा रहे हैं, उसको फिर वापस कर लेंगे. Now, triangle method is when you choose 2 points on the line. The line of best fit है. कैसे line of best fit है गौर से देखना. This point is above the line. If you can look closely, this point is above the line. This point is below the line. This point is above the line. This point is lying on the line. This is somewhere above the line. So make sure कि तुम्हारे पास जब तुम line of best fit बनाओ और वो curve of best fit बनाओ तो तुम्हारे पास plus minus 2 points हो. मतलब दो पॉइंट्स अगर ऊपर है तो 2 पॉइंट्स या 3 पॉइंट्स नीचे हो. ऐसा नहीं हो सकता कि लाइन बनाओ बेस्ट फिट की और 2 पॉइंट्स नीचे हो और 6 पॉइंट्स नीचे हो और 2 पॉइंट्स ऊपर. दैट्स गोइंग टू बी रॉन्ग. सो द लाइन ऑफ बेस्ट फिट इज द लाइन दैट कट्स थ्रू द स्कैटर पॉइंट्स. ओके, ये मैथ में भी करा चुका हूं. खैर एनीवे, सो वी पिक अप 2 पॉइंट्स ऑन द लाइन. आई एम गोइंग टू पिक अप, मैं पिक करता हूं, कोई नहीं, इंक्रीज द साइज and use a bright color. So I'm going to pick up 2 points. I'm going to pick up this point and I'm going to match it. Whether you choose this point and this point, that's absolutely okay. Whether you choose this point and the origin, that's absolutely okay. The answer for origin is going to be the same. So in your handout that I gave you yesterday, उसमें मैंने कोई और point choose किया. अभी हम कोई और point choose करते हैं. That actually doesn't matter. Why? Because it's a straight line. The answer for straight line will always be, the gradient for straight line will always be equal. Now you need to understand, whenever the examiner asks you to find out the gradient of a straight line, you are to use the triangle method. This is what the triangle method looks like. So if you look closely, in the triangle method, you have a 90-degree triangle made on the graph. It has to be made in such a way that it is visible when it is scanned. तो आप लाइट पेंसिल तो यूज कर ही नहीं सकते और आपने ये 90 डिग्री का मार्क बनाना ही बनाना है. 90 डिग्री का मार्क नजर नहीं आ रहा फर्स्ट करो तो 90 डिग्री लिख जरूर देना, because this is what is required. Now you need to understand, from this point to this point is rise and this point to this point horizontally is run. Okay, we'll do rise upon run, you can do change in y upon change in x. मैं rise upon run से कराता हूँ, आप change in या y2 minus y1 दो coordinates लेके y2 minus y1 math वाला formula लगा लो. That's absolutely okay. So the rise, I guess this point is 2, because this is 4, this is 6, this is 8, and you have 10. So I guess it's starting to go up from 2, and it has gone up to 50. What do you think? From 2 to 50. If I look very closely, it's not 50, it's 48. So it's not 50, it's 48. You need to be careful about all of this, okay? So from 2 to 50, the rise, I guess, is from 2 to 50 is 48 over the run. The run is the horizontal distance that the graph covers. The horizontal distance is starting from 0. That's a good point to start off with. And then it goes on up till 0.72. If you look closely, this is 0.72. So 48 over 0.72, because you see a line with a positive gradient, please make sure that you give your answer as a positive gradient. Even if you find out the gradient using rise upon run and you see a line with negative gradient, at the end, include the minus sign, okay? 48 upon 0.72, because I use different values, let me use the calculator. That's going to be 66.666667, which is coincidentally, exactly the same as for values that we use, different values that we use. You need to understand for your ATP paper in physics, you can have experimental inaccuracy. By experimental inaccuracy would be G की value 66.6 exact आ रही है. But अगर आप की value 67 जाती है, acceptable. 65 जाती है, acceptable. 66.2 जाती है, acceptable. But if it's 64, or if it's 68, or if it's 67.8, these are usually out of the experimental accuracy. Experimental accuracy is defined as कि बच्चा जब कैलकुलेट कर रहा था या ड्रॉ कर रहा था तो उसकी रीडिंग्स में कोई इनएक्यूरेसी आ गई, तो वो दैट इज फ्रॉम योर रिजल्ट, वट एवर योर रिजल्ट इज. दिस इज अभी तो आज इस क्वेश्चन में तो डेसिमल्स में, होल नंबर्स में हो या कुछ भी हो, फ्रॉम योर रिजल्ट इट्स इधर प्लस माइनस 0.2 और इट्स प्लस माइनस 2 if it's a whole number. Okay, please make sure ये जरूर चेक कर लेना. So the gradient, you can find out the gradient by taking 2 points, but because you're conducting an ATP question, you're attempting an ATP question, please make sure that you draw the triangle on the graph. This is your duty, okay? So I'm going to go back to my original question. इसको मैं थोड़ा सा वो कर देता हूँ, sorry. So ठीक है, चलो, I'll change it later. Now we move on. Now इसका कमेंट पढ़ के दिखा देता हूँ. पार्ट एफ का कमेंट पढ़ो जरा. G present, yes, G आपकी वैल्यू लिखी होनी चाहिए, definitely. And triangle method seen on graph. And what is the connecting word? It's and. So you're not getting any marks. It's a one marker. You're not getting any marks if you write down the gradient correct, but you don't draw the triangle. So please make sure you're very careful about it, okay? Now it says, explain why it is more accurate to measure the time for 5 oscillations rather than 1 oscillation. 1 oscillation में आपको मैं पहले ही बता चुका हूँ, टाइम बड़ा ही कम हो जाएगा आपके पास. जब आपके पास टाइम कम होगा तो आप स्टॉप वॉच को, सब और मैं ये एक्सपेरिमेंट कर रहे, तो सबा को स्टॉप वॉच स्टार्ट करने में और स्टॉप करने में बहुत मसला होगा. तो इतनी जल्दी रिएक्शन टाइम भी कोई चीज होती है, राइट? So you need to understand, you take 5 oscillations, and I gave it a trial run. Why? Because I was checking if even if 5 oscillations were enough to measure the time. So you need to understand, the greater the number of oscillations, the greater the amount of time you have to start and stop the stopwatch. Okay. Then it says, describe how the experiment could be improved to make the readings more. Okay, timing errors थोड़ा सा discuss कर लेते हैं. It says timing errors हो सकते हैं, could occur due to short time of start and stop, which leads to human error. Okay. Describe how the experiment could be improved to make the readings more reliable. Sir, whenever you are to make an experiment more reliable, you will have to repeat the experiment and find out average value. तो हम फर्स्ट को अल्फा स्कैटरिंग एक्सपेरिमेंट की बात करते हैं, जो गीगर और मार्सडन ने कंडक्ट किया. तो तुम्हें क्या लगता है, वो उन्होंने एक ही दफा कंडक्ट किया होगा और अपनी थ्योरी दे दी होगी? एंड इवन इफ दे डिड इट वंस, देन सबसे पहले रदरफोर्ड ने किया, फिर गीगर और गीगर मार्सडन ने, एंड they would do it repeatedly until experimental inaccuracy is eliminated and they're very sure of their results. So whenever you are doing a practical, you should always and always, to improve the accuracy of the experiment, Repeat the experiment multiple times and find out average values of the results that you've gotten. So this was the end of first question. Let's move on to the second question. The second question is extremely important because there is a lot to learn in the second question. Because ये one complete oscillation की length मांगता है. अब मुझे कैसे पता चलेगी? That's going to be a question that I will ask myself. Okay, चलो जी. Question number 2. A student investigates the period of a pendulum. Period का मतलब है, इसके ऊपर मैं लिख देता हूँ, sorry, time period for one oscillation. Time taken for one oscillation. एक पूरी oscillation complete करने का कितना time होता है? That's what we call time period or period for an oscillation. This is an oscillation, इस तरह waves भी हो सकता है, right? A student investigates the period of a pendulum. Figure 1.1, 1.2 shows the apparatus she uses. There is a clamp and there is Mr. Bob, metal Bob, right? At the end of the thread. I want you to make sure of one thing. Please look closely. I'm going to zoom it for you. If you look very closely, this dotted line aligns with the center of the bob. This aligns with the center of the bob. So if you were to take readings using your meter rule or whatever measuring instrument you take, you make sure that your eyes are open to check if it is with the center of the center of mass or center of gravity of the bob. Okay. I'm going to put the set square again. Now you see this triangle is a set square. It's a meter rule. ये अभी हम बताएंगे आपको कि क्या होता है. Okay. It says explain briefly with the help of a diagram how you would use a meter rule and a set square. A set square is this triangle that you have in the geometry box that you will always use to verify, justify, prove that either your eye position was perpendicular or whether the rule is perpendicular. So it is one way of proving that two lines are perpendicular to each other. Okay. Explain briefly with the help of a diagram how you would use a meter rule and a set square to measure the length d of a pendulum as accurately as possible. तो अभी ऑसिलेशन की बात ही नहीं की है इसमें. मैंने यही वाला डायग्राम यहाँ पे मैंने इस पे लगा दिया था. मैंने इसको मैंने स्क्रीनशॉट करके यहाँ लगाया. देखो, if you look closely, please make sure that your meter rule is aligned and your meter rule has to be longer than the clamp, longer than the thread. Yeah, clamp कर लो तो बहुत ही अच्छा हो जाएगा. Understood? So that's one thing that you have to keep in mind. Sorry, I'm going to put it back. This meter rule has to be longer than the clamp or at least longer than the thread. If I look closely at this, I would want to increase the length here. Sorry, ये मेरी mistake है. सही है, but थोड़ा सा और extend कर देना so that you can easily take out the readings from the top and from the bottom. Now it says, explain briefly. So that the command word is explanation with the help of a diagram. When it says with the help of a diagram, you have to, no matter what you feel like, you have to draw the diagram. You may draw a diagram में छोड़ देना, option होता है, but when it says diagram is necessary, it tells you as accurately. So what I'm going to do is I'm going to put a meter rule very close to the clamp. मैंने ये फिर भी दूर लगाया है. ऐसा नहीं करना कि मीटर रूल अगर तुम यहाँ लगा रहे हो तो obviously it's not going to measure properly and you can have reading issues, right? So please make sure that whenever you place the meter rule, you place it close to the clamp or close to the thread. Okay. Then why did I use a set square? A set square will always have this. It will always have a 90 degrees. This is right angle triangle. You have two set squares in your question, in your geometry box. So this set square is actually a set square where both the lengths are equal. And then this angle would be 45 and this is 45. So it's 45 and 45. This is what you call a 90, 45, 45 set square. And then when we talk about the other set square that you have in your, it has one of its length longer than the other. This set square is actually 30 degrees, 60 degrees, and 90 degrees. All these angles should be equal to 180 degrees. So whichever set square you use, it is a right angle triangle, and whenever you have to show it is perpendicular, you have to make sure you draw the bob, you draw the set square in the way that I've drawn. Okay. Now it's a 3 marker. Very rarely do you see 3 markers in an ATP question, and these are all very latest questions. So please make sure you understand all of them. Now it says it's a 3 marker. It says 1 mark is for the diagram. Because you are to take readings from the meter rule, you are to place your eye position. So placing your eye position, how to place it, where to place it, mention whether it has to be in perpendicular to the scale reading, whether it has not to be at an angle to the reading. Please make sure कि placement का एक mark है, placement of your eye, okay? उसको explain करने का एक mark है. Now it says the eye must be placed perpendicular to the reading. On the meter rule at two places. Why at two places? Why? Because you're taking two readings, and two readings means one at the top and one at the bottom. It says beneath the clamp and in line with the base of the set square. Okay, beneath the clamp is this position. Dekhna beta. Beneath the clamp is this position. So you have to place your eye here, and you have to place your eye here so that it is in line with the base of the set square. That is where you get 3 marks. So one for the diagram, one for placement of eye, and one for mentioning that because you're taking two readings, you have to place your eye two places perpendicularly. Okay. Then you have the student adjust the pendulum so that D equals to 50 centimeter. Okay, what is D, sir? What is D? D is the distance, right? She's displacing the bob slightly. थोड़ा सा slightly बोला है तो थोड़ा सा उसको हिलाया. तो अब it starts oscillating. इधर जाएगा, इधर जाएगा, इधर जाएगा. And obviously, because it loses energy over time, a lot of heat energy, a lot of your kinetic gravitational potential energy converts to heat energy. After a certain period of time, it's going to come back to its mean position. Okay. Now it says the student adjusts the pendulum for so that D equals 50. She displaces the bob slightly and releases it so that it swings. Figure 120 shows the complete oscillation of the pendulum. She measures time T1 for 20 complete oscillations. This time is for 20 oscillations. This is not for one oscillation. Okay, record the time T1. So it's 28.12. You see this 1 upon 100. ये अगर 1 upon 1000 होता है तो please make sure ये अगर ये 1 upon 1000 होता तो हम इसकी क्या reading लेते? It would have been 28 seconds, yes, plus 12 upon 1000. 12 upon 1000 is 0.012. Please make sure examiner यहाँ खेल सकता है आपके साथ. It's going to be 28.012 seconds then. ये reading हम अक्सर stopwatch पे ignore करते हैं. Don't do that. Just don't do that. Okay. It's 28.12 seconds in this case. बहुत आसान था. Calculate the period T1, capital T1 of the pendulum. The period is the time for one complete oscillation. If you have the time for 20 oscillations, which is 28.12, then T1, the time for one oscillation is going to be 28.12 divided by 20. इसका एक मैंने formula आपके लिए बनाया है. आप देख लेना. It's just basic unitary method, right? 1.406 seconds. Now, the student adjusts the pendulum until the distance is 100 centimeters. It was 50 centimeters. Now it is 100 centimeters. She repeats the process and records the time T2 for 20 oscillations and the period T2. Sir, अगर 50 centimeter पे था, तो हमें 28.12 seconds मिल गए थे. 50 oscillations. I just want to draft a relationship between distance and the number of oscillations. If it was 50 centimeters, you completed 20 oscillations in 28 point something seconds. So it's 28.12 seconds, right? Now, when the length of the thread is increased to 100 centimeters, you're taking more time. Why are you taking more time? What relationship can you draft out of all of this? Because इसके ऊपर question आया हुआ है. Next part में ना इसमें relationship हमेशा draft करने को आएगा. So either if the examiner gives you a table and asks you to draft a relationship, you can look at the values and see the change. Or it is necessary for you to compare between T1 and T2 or small t1 and small t2, right? So when the distance is increased, the time is also increased, right? So I guess if the distance of the distance d of that is the length of the thread increases, the length increases, then the time it takes, time taken for 20 complete oscillations also increases, right? So they are proportional, not directly proportional. You're going to use the word directly and inversely very carefully, because if you write down directly proportional when they were proportional, you're not going to get a mark. तो हमें लगता है कि ATP हम पेपर दे के आते तो ATP बहुत अच्छा हुआ, मगर ऐसा नहीं होता है. Why? Because छोटी mistakes examiner marks काट रहा होता है. Because for an experiment that is actually conducted in the lab, you have to be extremely careful. That is why ATP का paper messes your grade up. Either it brings your grade up or it messes it up. So if the length increases, the time also increases. Okay. Now, अब वो देखो बेटा, जब ये बॉब की बात हो रही है ना, अगर हम कहते हैं ये डिस्टेंस है, ये सेंटर ऑफ मास से लेके ये डिस्टेंस है, अगर हमने देखा कि डिस्टेंस हमने डबल कर दिया ना, 50 से 100 कर दिया, तो हमारी टाइम बढ़ गया। तो आई नो फॉर अ फैक्ट दैट फैक्टर्स अफेक्टिंग टाइम, चाहे वो टाइम पीरियड हो, चाहे वो टाइम टेकन फॉर 20 ऑसिलेशंस हो, that is affected by distance definitely. But you need to understand, if I place a heavier bob, will that affect the time? And now the examiner is telling you कि अब मैं bob का size change करता रहता हूँ, उससे देख के बताओ कि हमारा time taken for 20 oscillations बढ़ता है कि नहीं बढ़ता. So you are going to be very careful, because in the last part it's going to ask you for a comparison between the time taken for 20 oscillations when the distance changed and the time taken for 20 oscillations when the mass changed. तो बड़ा क्लियर रहना. आपको लगता है आप जल्दी करना है, आपने बहुत तमीज तरीके से चलना है. दिस इज क्वेश्चन वन मोस्ट प्रोबेबली, एंड दिस इज डेफिनेटली अ पार्ट ऑफ योर एटीपी. इसको आप इग्नोर नहीं कर सकते. इसके आपके पास पास्ट पेपर्स में बहुत है. आई एम गोइंग टू डू 3 क्वेश्चंस, उसके बाद फिर आप इसको बाकी अटेम्प्ट करना. इट सेज शी मेजर्स द मास ma of the pendulum bob. The reading on the balance is shown. ये बैलेंस स्प्रिंग बैलेंस हो सकता है? नहीं सर. क्या ये बीम बैलेंस हो सकता है? यस सर. क्या ये फैन बैलेंस हो सकता है? यस सर. क्या ये इलेक्ट्रॉनिक बैलेंस हो सकता है? यस सर. Because spring balance is a balance that measures weight. So you can use the spring balance to measure mass, but you first find out weight and then divide it by the constant for gravity. Okay. Now it says it is 51.65 लिखा हुआ है. कहता है करेक्ट टू द नियरेस्ट ग्राम. नियरेस्ट ग्राम मतलब नियरेस्ट 1 ग्राम. ये बात याद रखना कि होल नंबर में इसको आंसर चाहिए. तो 51.65 can be rounded off easily to 52 grams, and I'm sure इतना तो आपको estimation approximation आता है. That's a free mark. अब यार Sabha, if you look closely, the mass of the bob was 52 grams. Now it has gone up to 109 grams. तो 109 ग्राम्स के बाद ना ये रिजल्ट आ रहे हैं इसके पास. ये सारी चीजें लिखी हुई हैं, आप इसको जज करेंगे और फिर देखेंगे कि क्या अफेक्ट करना है. नाउ उसने बोला जब डिस्टेंस डी 50 सेंटीमीटर से अब मास चेंज करने के बाद भी उससे डिस्टेंस निकालेगा. डू यू अच्छा रुक जाओ. यूजिंग द रिजल्ट T1 T2 T3 एंड T4 फॉर योर ईज, मैंने सारी वैल्यूज ऊपर की सारी वैल्यूज हमने निकाली थी, उसको पहले यहाँ लिख दिया. So the first T1 is 1.406, second is 1.99, second is 1.3 is 1.39, fourth is 2.02 second. अब जो मैंने आपको कंपैरिजन वाला बोला था वो ये आ गया लास्ट D part 1. It says using the result for the period of each pendulum, take the response that matches your result and stay within the limits of experimental accuracy. थोड़ा बहुत experimental accuracy निकालना. मैं अब बताता हूँ to counter this question. 4 वैल्यूज जहां गिवन है, 3 वैल्यूज जहां गिवन है, 2 वैल्यूज जहां गिवन है, 10 वैल्यूज जहां गिवन है, प्लीज डू एन एक्स्ट्रा एफर्ट, फाइंड आउट द एवरेज. इट सेज all values of t are within experimental accuracy of the average value. जो तुमने पहले एवरेज वैल्यूज निकालनी पड़ेगी. आओ एवरेज वैल्यू निकालते हैं. हाउ डू यू फाइंड आउट एवरेज वैल्यू? इट्स T1 plus T2 plus T3 plus T4. That's the next part. चलो उसको बाद में करते हैं. Looking at your result, the period t is affected by distance only. That's a fact. ये तो होना ही होना है. अच्छा, उसके बाद क्या है? The period t is affected by both d and m. Yes, it is affected by d, but it is not affected by mass, because mass a कितना था देखो. mass a 52 grams है और mass b 109 grams है. अगर 52 grams हो या 109 grams हो, ये वैल्यूज जो t की आ रही है ना, ये सारी वैल्यूज विद इन एक्सपेरिमेंटल एक्यूरेसी है, मतलब प्लस माइनस पॉइंट प्लस माइनस 2 के अंदर अंदर है. तो दिस टेल्स अस कि मास अफेक्ट नहीं कर रहा था, डिस्टेंस जरूर अफेक्ट कर रहा था. बिकॉज जब डिस्टेंस 50 सेंटीमीटर होता था तो टाइम टेकन फॉर 20 कंप्लीट ऑसिलेशंस वाज 28.12 seconds, and when it went up to 100 centimeters, the time changed significantly. 28.12 से 39.8 पे जाने में आप एक्सपेरिमेंटल एक्यूरेसी के बाहर हैं. जहां आप एक्सपेरिमेंटल एक्यूरेसी के बाहर गए, इसका मतलब है कि वो फैक्टर अफेक्ट कर रहा होगा टाइम टेकन. ओके. Now it says justify your answer. Now you can justify your answer by, if you have more than one value, then you can justify your answer by finding out the average value. So T1 plus T2 plus T3 plus T4 divided by number of observations that are 4, 1.7015 तुम्हारा average value है. अब 1.7015 is the base. ये सारी values 1.7015 के round about करीब होनी चाहिए. I think सारी बहुत करीब है. That is why we say yes, they are within and the mass does not affect. Now यार ये बड़ा important part है. E part 1, this is very very important sir.
This is what you call the protractor rule. Boys and girls, the time is about to be over. दूसरी मीटिंग स्टार्ट करो, जल्दी से अब आप ज्वाइन करो. ओके, थैंक यू सो मच.